I received a phone call about an hour ago that a cousin of mine who's 52 years old had a massive stroke and has been induced into a coma and on a ventilator. And his family has to make a very dire decision whether they should take him off the ventilator, which basically would ensure his passing. The alternative is that if he recovers, he will virtually have no cognitive function. 52 years old. Now, this is a result of the complications of diabetes. That's what this is. Now, furthermore, 3 months ago, on the other side of my family, on my mother's side of the family, a cousin, 58 years old, had a massive stroke, was put on a ventilator, induced into a coma, and passed 3 months ago as a result of complications of diabetes. 4 years ago, my cousin who passed away from the complications of diabetes 3 months ago, his brother, who at the time is 54, died of complications of diabetes. This is why I do what I do. You know, diabetes is so many people have it, right? And the fact that so many people have it, people don't really take it seriously. They think that if my doctor puts me on medications like metformin and gets the blood sugar somewhat under control, that I can just continue living my life and doing the things that I do, and there's no issues. That they think of it as just some separate thing that's being treated, and not understanding the fundamentals of what's going on physiologically, right? The damaging effects. So now take a breather, but I want to just kind of show you some things so you get an understanding of this, right? Now this is just to kind of give you a little insight and kind of wet your whistle here a little bit. Let me share the screen, all right, to show you some stuff here. How do I share the screen here, Cynthia?
Go to your Zoom, like open.
Okay, share the screen. Okay, get out of here. Okay, am I okay with this, Cynthia? Just bear with me.
Yes. Yeah, so just minimize this because you don't need it. You're trying, so go all the way over here.
This?
Yep. And then you're using
I see. All right, thank you, Cynthia. All right, let's just get to some fundamentals here. Bear with me. There it is. Okay, hopefully everybody can see this. Is this large enough? Okay, everyone, look. So what I want to show you here is like really what is diabetes? We hear this word, this name diabetes, but really what is it, right? And again, I'm not talking diabetes. I'm talking about blood sugar and blood sugar dysregulation. So hopefully before this is over, you'll have just a fundamental understanding of this. And I am begging you all, whoever is listening to this, to share this information with other people that are important in your life, please. Okay, but listen, so what happens is this: when we eat our food, right, your blood sugar is going to go up, right? It's called glucose in the blood, and your body has to do something with this. So simply put, when I talk to people about blood sugar and diabetes, and I ask them, here, let me back up. I have people that I see that come into the office that are actually diagnosed with diabetes, and they're seeing a doctor, they're seeing a diabetic doctor, or they're working with a nurse practitioner that's managing their diabetes. And I say, okay, fine, you're managing your diabetes, great. And I ask them, can you tell me what diabetes is? And I never really get an articulate answer. And it's not their fault, right? It's because no one's really explaining it to them, right? So how is an individual who has the condition really supposed to take control of this to make improvements, right? If they don't really even understand it. It's not the fault of the person, it's the fault of the treating people, the treating doctors. So let me just, when you eat food, your blood sugar goes up, quote glucose. Now we can agree that some foods, like candy and cakes and donuts and whatnot, right? They're going to cause your blood sugar to go up faster and in a higher volume than if you're eating vegetables. Okay, but nonetheless, your blood sugar goes up. So as soon as the blood sugar goes up, your pancreas is activated. It releases a hormone called insulin. Insulin is a hormone, and insulin acts like a taxi cab. It literally scoops up, it picks up glucose like a taxi cab, picking up a passenger. And now it's transporting it around the body through the blood system, and it wants to bring it to the individual cells, all of the trillions of cells that make you, you. Okay? Now, here is a picture that I created, which is a diagram, a picture of what we call a healthy cell, right? And this blue circle here is describing the membrane, okay, that holds the cell together. And that's 2 layers of fat. Okay, and that membrane, because there's 2 layers, is semi-porous, which means things can pass in and things can pass out, right? So we want to get nutrients into the cell, and we want to get toxins out of the cell. That makes some sense. On the cell wall, right, is you have what we call receptors. I kind of like to describe it as like a boat looking for a dock, right? The dock is like a receptor. And so your cells have receptors for virtually every protein, okay, that needs to lock on. So in this case, we're looking at what we call insulin, the hormone insulin, right, and an insulin receptor, right? So as the insulin is carrying the glucose through the body, through the blood system, right, it wants to find a receptor or a dock to lock onto. Once the insulin locks onto that receptor, the glucose that it's carrying gets inside the cell. That's what we want, right? I always talk about like the party takes place inside your cell. Now, inside your cell, right, you have in the middle is the nucleus, which carries your genes, your DNA, your genes, right? Your genes is the instruction sheet that says, okay, what proteins should I manufacture? Should I become a kidney cell? Should I become a heart muscle cell? Should I become a hormone? What am I going to become, right? That's the protein structure. But in order to do this, your cells need to make energy. This is really metabolism 101. So inside your cell, you have what are called mitochondria. Many of you have heard that, right? That is the engine or the power plants or the battery we talk about, where you make energy, right? We're not going to get into all of that today, but some cells literally have like a couple of hundred of these mitochondria in there. And then there are cells that make up your heart muscle, for example, and your brain cells and your muscles, where you might have upwards of 2,000 tightly packed mitochondria. Why? Because your brain and your heart, right, and your skeletal muscles use up a lot of energy. So they have a lot of mitochondria, right? But it's the glucose and other nutrients like oxygen and magnesium and hormones that got to get in it. But glucose needs to get in here, and it needs to get inside your mitochondria. And it's in this engine where you then utilize that glucose and oxygen and nutrients to make energy molecules. And the byproduct of making this energy, okay, is you produce toxins called free radicals. They need to be quenched by certain specific types of antioxidants like glutathione, and they're escorted out of the cell, and then hopefully brought to your kidneys, where you clear them out through your liver to your kidneys, and you excrete them out. Right? That is literally metabolism 101. Literally, I explain to people it's no different than your car. If you fill your tank up with gas, I got a full tank of gas, but I have to get the gas to the engine. It's a fuel line that brings the gas to the engine. And then when it gets to the engine, it combusts to form power. And you hit the accelerator and the car can go down the road, right? And out the tailpipe goes carbon monoxide. Well, we're not living on gasoline, obviously, right? But we're living on glucose and oxygen and nutrients, right? So that's metabolism, right? When you hear the term insulin resistance, right? This diagram here, right, is showing us insulin resistance, right? We call it cellular inflammation. So here you see the wall of the cell is different. I color it in red for a reason, right? So the healthy cell, the cell wall is semi-permeable, and we can get the nutrients in and get the toxins out. But when we have what we call cellular inflammation, another word we hear is called oxidative stress, interchangeably the same things, but the cell wall literally kind of starts to rust in a way. It gets hard, and it gets more difficult for the nutrients to get in there and the toxins to get out, right? It's almost like putting a cork into the tailpipe of your car and getting the carbon monoxide to back up into the engine. But on the cell wall, what begins to happen is those receptors can start to turn off. So here we're talking specifically about insulin. So insulin is a hormone that goes up when your glucose levels go up, right? And it picks it up and it's transporting and it wants to find a receptor, an insulin receptor. So if it can find an open receptor on the previous cell, it locks on the glucose, gets inside your cell. That's what we want. In the case of insulin resistance, the receptors turn off. So there's no place for the insulin to lock on. It's like my example always is like if we're all sitting on a boat in the middle of a lake and we want to go off, we want to go to shore because we want to go eat, the boat has to go to a dock. But if all the docks are taken up, there's no place for the boat to dock. We can't go to shore. We're stuck in the middle of the lake. So what happens is the insulin can't lock on, which means the glucose that it's transporting is not getting inside your cell. If it's not getting inside your cell, right, then you've lost the fuel delivery for your mitochondria to make energy. You're not going to make sufficient energy. The cell does not have enough energy to function properly, and things can go awry.